Alright, here we are on our second lesson of Chapter 6, and this one is on Pythagorean Identities. So this is still part of 6.1 in your textbook. So identities, again, it's going to be something that is true for every single value of x. And Pythagorean gives you a little bit of a hint because you know about how Pythagoras works for right triangles. Let's see. Here, let's consider what we know about the unit circle. And over here is a nicely drawn unit circle. Let's just draw a radius here to some point. So this is some point here, and we can make a right triangle out of this. And we would have an x value, so out of this point here we could have an x value and a y value, where this side is the x and this side's the y. What's the hypotenuse? Well, for the unit circle, that hypotenuse is always 1. And you'll remember how your Pythagoras works. Pythagoras is, well, we often say c squared equals a squared plus b squared, but in this case we could say x squared plus y squared is equal to 1. And if we recall from the previous chapter, that's also the formula for a circle, where this would be the square of the radius. So if I put a squared there, it actually doesn't make any difference. So this has a radius of 1. But if we change this around and you realize, hey, another way of looking at this triangle is that we remember on the unit circle that x is the same thing as cos. So in our unit circle, we could say cos squared of theta plus y, not y, but where's my eraser? But the sine squared of theta is going to be equal to 1. So that is our first Pythagorean identity, and for some reason we usually put sine first, so I'll write it that way. Sine squared theta plus cos squared theta is equal to 1. I'm just going to pop over to our formula sheet. So this is the formula sheet this year for the pre-calculus exam. This is what you're going to get on exam day, and you'll see, okay, this is the first formula that we used in a previous chapter 4, and here is this Pythagorean identity we have there. Sine squared theta plus cos squared theta is equal to 1. Oops. So if we wanted to try this out for a value, what you could do is you could say, oh, let's pick a value for theta, and let's say you did sine squared, and you picked a value of theta of I don't know, like say pi over 2 plus cos squared of pi over 2, and you found out what it was equal to. So for here's 0, right? Here's pi, here's pi over 2. And so the x value is equal to 0, the y value is equal to 1, so we would get sine of pi over 2 is 1, and since that's squared, we'd say squared plus 0 squared is equal to 1. So that would be an example to verify it for a 1 solution. So we know that it's true for at least 1. It's an identity because we know it's true for all values, not just the one that we picked. It's true for all of them. There's 2 other forms you can have. So if you're going to solve for cos squared, if we take cos squared theta by itself, we'd have to subtract both sides by sine squared theta. So another version of this would be cos squared theta is equal to 1 minus sine squared theta. So be on the lookout for that format, this 1 minus sine squared theta. You're going to encounter that a lot. And the last one is if we're going to isolate for sine squared theta is equal to 1 minus cos squared theta. So very similar again. Okay, there are 2 other Pythagorean identities, and you can see them from our formula sheet. So these are the next 2 that we're going to do. Tan squared theta plus 1 and 1 plus cotan squared theta. So we'll put them in here. So the first one is 1 plus tan squared theta is equal to secant squared theta. That's the first one, and the other one would be 1 plus cotan squared theta is equal to cosecant squared theta. So just a reminder that you don't have to memorize this. Okay, this is on the formula sheet. So you can have that formula sheet for all your quizzes and for all your tests, so you don't have to worry about that. Let's just see if we can do a quick little proof of this. So we haven't started our formal proofs yet in this unit, but we'll be doing this later on. So one thing when you do a formal proof is that you want to work with either the left-hand side or the right-hand side one at a time. So what we're going to do is we're going to work with the left-hand side here. So I'm going to say left-hand side is equal to 1 plus tan squared theta. And I'm going to work with that until hopefully I can make it look like something on the right hand squared. So tan squared theta is the same thing as sine squared theta over cos squared theta. And I'm thinking about my 1 here. If I want to have if I want to be able to add these together, I need to have a common denominator. So I'm going to rewrite 1 as cos squared theta over cos squared theta. Now I can add these two things with a common denominator. So I'll have cos squared theta plus sine squared theta, sine squared theta, all over cos squared theta. Alright, so looking at this numerator, hopefully we'll see, hey, that looks like something that we just did, right? It's in the same order, or it's in a different order, but still it's going to be equal to 1. So this is going to be equal to 1 over cos squared theta. And 1 over cos, the reciprocal of cos is equal to secant, so the reciprocal of cos squared will be secant squared theta. And now I'm going to say that's the same thing as my right hand side. So I was able to say that the left hand side is equal to the right hand side, so I proved it. Okay, so that's how our proof works. Now this won't be a required proof. It'd be a little bit on the hard side for some of our proofs, but it's something that we're going to be learning how to do. Let's see if we can do the same one for our 1 plus cotan squared. So again, I'll divide this up into left hand side and right hand side. I'm going to work with the left-hand side here, so I'm going to say LHS, left-hand side is equal to 1 plus cotan squared theta. Similarly, now if tan squared was equal to sine squared over cos squared, this will be equal to cos squared theta over sine squared theta. And again, my 1, I will change that to sine squared theta over sine squared theta. And now when I put this together, I'm going to get this sine squared plus cos squared. Sine squared theta plus cos squared theta all over sine squared theta. And so this, again, this numerator here, that is going to be equal to 1. And I'm going to very happily say 1 over sine squared theta, which should be equal to cosecant squared theta. So this left-hand side is going to be equal to my right-hand side. Cha-ching. Very nice. Okay, so I was able to prove those other two Pythagorean identities. Using Pythagorean identities to simplify expressions. So this is like we were doing previous. Up until now we had the reciprocal and the quotient identities from our previous lesson, and now we're going to be doing the same thing now with these Pythagorean identities. So let's see if we can make this happen. Simplify each expression to a single trig function. 1 minus cos squared theta. So right away we're bringing out the this 1 minus cos squared theta. So here it is, that 1 minus cos squared theta, and that's the same thing as sine squared theta. So in our very first step, we can say, oh, okay, this is going to be equal to sine squared, no, it's not theta, it's x, so I'll write an x in here, all over sine of x. Okay, this simplifies just similarly to say x squared over x is equal to x. It's the same idea. This is sine x times sine x. So this simplifies merely to 1 over the sine of x. And that is a reciprocal of cosecant of x. And there is our answer. So we want it down to a single expression, so a single function. All right, 1 plus cotan squared theta. So again, I can say, hey, I think I got one like that. 1 plus cotan squared theta. That's right over here. It's one of my brand new, try it again. It's one of my brand new Pythagorean identities, 1 plus cotan squared theta. So that's equal to cosecant squared theta. So I'll write that in here, is equal to cosecant squared theta all over cosecant theta. Well, isn't that great? So we're pretty well done here, and that simplifies to cosecant theta, because I got a squared version of it in the numerator and just a cosecant theta in the denominator. And there's my answer. It's really quite short. Okay, let's try out example number 2. Simplify each expression to a single trig function. All right, so how about we're going to take this approach here to say, why don't we put everything in terms of sine and cos? So secant is the reciprocal of cos. So here I'll say 1 over cos theta minus, now this is going to be sine theta, multiplied by tan is the same thing as the sine of theta over the cos of theta. Okay, so now I'll get 1 minus the cos of theta minus sine squared of theta all over cos theta. Okay, so I have two terms here with a common denominator, so I can put them under as the same fraction in with the same denominator, 1 minus sine squared theta. And now you go, oh, I think I've seen that 1 minus sine squared theta. Yes, it is. That is the same thing as cos squared theta. So that's where we're using our Pythagorean identity, cos squared theta divided by the cos of theta. And now I'm going to cancel a cos from both the numerator and the denominator. So it simplifies down to the cos of theta. There we go. All right, one more example here. I have the cosecant minus sine all over cotan. Let's use that same method. Let's put everything in terms of sine and cos. So cosecant is the same thing as 1 over the sine of x minus the sine of x all over, now cotan is equal to the cos of x over the sine of x. All right, so you see how it's going to be pretty similar to what happened on the left-hand side here. If I'm looking at this numerator part, and I can say, oh, I've got this sine x here. If I need to combine these two fractions, it's going to be sine squared x over sine of x. So I'm just going to switch to a pen that's a little bit smaller. 1 over the sine of x minus sine squared of x all over the sine of x all over cos of x minus or over the sine of x. So now when this goes over when I combine these two fractions, because they're both over sine of x, I get 1 minus the sine squared of x all over the sine of x. And then the bottom of my fraction is the cos of x over the sine of x. Be careful, avoid the temptation of trying to combine a lot of these terms, a lot of these steps. Okay, show your steps along the way. And I'm going, oh, I know this is going to be 1 minus sine squared. I could switch it to cos squared already. You really need to show each of your steps so that things don't get all confused. So here, this 1 minus sine squared of x is going to become my cos of x. So I'm just going to go up here for my next step. So I will change my 1 minus sine squared to cos squared of x over the sine of x. And now instead of dividing by this fraction, I will multiply by the reciprocal. So that would be the sine of x over the cos of x. And now I can do some simplifying. I can say, oh, the sine of x's, if I divide both the numerator and the denominator by sine of x, those turn into 1. And I can divide by a cos of x. So this will get cancelled out, and the squared part will get cancelled out. And so my final answer is the cos of x. And that is my answer. Okay, so Now it's time for you to practice. So we've got 6 questions. It's not a lot, so those ones we'll be doing in class. See you then.